Oh, greetings, everybody. This is a question somebody sent me from my math lab, and I think it's a good question for me to show you and for me to add to the video list. So I'll solve this problem in 3 parts, which I've worked out separately. I've worked it out already, and I'll walk you through the steps that you see here. I guess before I get started, I have a friend joining me today. Look at this. That's Gimli, and he just had surgery, so he's taking it easy with me, and we're doing a little math today. And then I've got my cat Luna back there on the couch. She's keeping a close eye on the dog. But I think he'll be good during the video, so it won't be a problem. So here we go. So the question is about that we have a function or curve, those words which I use interchangeably. The reason I might say curve is because I think that you learning this entire concept is somewhat visual in addition to mathematical. So I might graph the function and refer to it as a curve. There it is. F of x is x squared minus 5. We could also say y equals x squared minus 5. X and y are the variables. And then I have a point that I'm interested in on that curve. Negative 5 for x, 20 for y. I can verify that point's on the curve as it should be if this question is properly framed, because I put negative 5 in for x, I get positive 25 when I square it. I subtract 5 and I get 20. Okay, so that point is indeed on this curve. You can verify the x's and the y's. Now, the first question on my math lab, it says use this particular formula to find the slope of the tangent line to our curve at the point that's given. So the way that that would look is like this. I have the formula that it says to use, and that's the one that I'll insist you use on the test. There are other ways to do this. I'm not at all saying that this is the only way to solve the problem, but this is something that everybody who takes calculus absolutely must learn. Okay? In this formula, which will tell us the slope of the tangent line to this curve at that point, x is just the variable in the function. It will remain as x. Okay? And then a is going to be the x-coordinate of whatever point we're trying to determine the slope of the tangent line at. So in our case, a is going to be negative 5 because the point that's given is negative 5 for x, 20 for y. Okay. Now, I will show you over here in 2 steps how I can calculate this. Before I do that, it wouldn't be right for me to leave out an explanation of why this will tell me the slope of the tangent line to the curve. So here I've drawn a sketch of what, roughly what this situation would look like. There's the curve there, which you see is curved. And then I have a series of secant lines drawn so that this point is pushed over to the negative 5. What happens to that secant line if I push this connecting point over to negative 5? Well, the secant line will align itself more and more to the curve until the point where they look the same. So this one that I've drawn the closest, look how it's overlaying the curve almost perfectly. It's not quite perfect, but I mean, it really looks a lot like the curve. It's almost right on top of it. You can hardly tell them apart. Imagine if I push this even further closer to that point. This secant line would begin to align itself more and more and more and become indistinguishable from the curve at that point that's given. That's what this does, okay? This f of x minus f of a over x minus a, that's the slope of any of these secant lines, and the limit as x goes to a just pushes them closer together. And what you eventually get as you push x to a is the slope of the tangent line, okay? So that's the theoretical explanation. You might not be interested in that, but it would be really negligent for me not to tell you real quick. Okay, so let's calculate this. I'm going to take this, and first I'm just going to do algebra. I'm just going to simplify it. I'm not going to worry about the limit till I'm almost done, okay? So let's take f of x minus f of a over x minus a with our curve and our point that a is negative 5. So here's what it's going to look like. Here's f of x, x squared minus 5, minus, and then here's f of a, which a is negative 5, so I put negative 5 into that, okay, over x minus a, where again a is negative 5, so it's going to look like that. Doing a little math, I'll get 20 there. That's not a surprise because we were told the y coordinate was 20, and it is. And then I'll subtract negative 5 minus 20. I'll get negative 25. So I've got x squared minus 25 over x plus 5. Could I take it any further? I want to simplify this. I want to get it as simple and basic as possible for whatever I'm going to do next with it. And so I can simplify it. I try to think of something, and I can think of something. I could factor the top, and then I could cancel. And so this whole thing just reduces to x minus 5. That's as simple as it's going to get. Okay, but I want to take this and I want to simplify it as much as I can. Now, I'm done with that part. The next part would be to apply this limit. So in my case, I got the limit as x goes to negative 5 of this, x minus 5. I can calculate this particular limit by just letting the x be negative 5. Maybe not all limits can be done that way, but this one can. It can because I have no issue with that formula. When I plug in negative 5, I get negative 10. Okay, so that tells me this. That tells me the slope of the tangent line to the curve at the point that was given is negative 10. That's actually a very steep line. Here's what it would look like. Now, this video is partly math, partly it's a demonstration of concepts. Okay, I took my ruler right here, and on paper, I drew a line that has a slope of negative 10 for you to get a feel for what we're dealing with. A line with a slope of negative 10 would go down 10 units for every 1 unit it goes over, because slopes rise over run. That's negative 10 over 1. So our tangent line is going to look like this. Okay, it's going to be that steep. It's going to be a very steep line, and it's going to go down and to the right very steeply. Now, I happened to peek ahead a little bit, and I did graph the curve and the tangent line together, and I'd like to show you that they really do. I mean, I drew this accurately. That's what it's supposed to look like. So here, now this graph I'll talk more about in a minute, but the tangent line is in blue, and look how like it looks like an extension of the line that I drew. That's how it should be. Okay, so when I try to get you to understand the concept of slope, and I say the slope of the tangent line is negative 10, and that's very steep, it means it would look like this because slope is rise over run. And I can get a ruler, I can measure that out, and I know what it's going to be like. Okay, so that is part A of our question. I found out the slope is negative 10, and so I'm going to put that in here. Or that's how we do things on my math lab, and I'll check it and it's right. Okay, all right, now next part of the question says, what is the equation of the tangent line? All right, so let's take a look at that. That part I have down here. Equation of the tangent line. Well, to give you an answer to that, there are two ways that we could express the equation of a line. Okay, there's what's called the slope-intercept form, and that looks like y equals mx plus b. And there's also the point-slope form, where we do y minus y naught equals mx minus x naught. You can use either one. It doesn't matter. You'll get the same result. I usually use, when I show people, the slope-intercept form. But here I've used both of them to show you how we use the information that we have to get the equation of the tangent line. So I start off by saying, this is what the answer looks like. The equation of a line, including a tangent line, which is just a line, is y equals mx plus b. And what I would need to find out of this is m and b. M is the slope. I've already found in part A that the slope's negative 10. So I put that in. Now I got to find b. What else do I know about this line? This line goes through this point. The tangent line to this curve at that point goes through that point. It's the one thing they have in common. This point's on the curve, but it's also on the tangent line. So I can use that information. I can say I know that the point where x is negative 5 and y is 20 is on the line. So that means I can put 20 for y and I can put negative 5 for x. That leaves only b to solve for, which I get, and it's negative 30. He sees the cat. He wants to play with the cat, so you'll have to excuse him. Okay, now over here I did the same thing. M is still the slope, but in this form, y naught and x naught are the x and y coordinates of the point that we're working with. 20 and negative 5. Okay, put that in. I'll get the same thing. The equation of the tangent line is y equals negative 10x minus 30. Okay, so we've got that. Let's see. It wants the equation in slope-intercept form. So I'll do negative 10x minus 30. And that's it. I know that that's right because I'm certain of the way that I derived it. And there you go. Last part, it says, can you plot the graph of the curve and the tangent line together? And I see these scenarios here, but I know what it should look like. It should look something like this. Now I'll use a online graphing calculator to do this, but I'll also show you, like, here's all the features that we're looking for. Okay, so I want to draw, or I want to envision this curve, which has this point on it. This curve is a parabola. Parabolas look like that. Okay, plus I want to impose the tangent line at the point, which has equation y equals negative 10x minus 30 on top of that. If I'm right about everything, then when I graph these together, the line should lay right on top of the curve at the point that we're given. Okay, so I got a parabola and I've got a line. The line has a slope of negative 10 and it hits the y-axis at negative 30. So that would look something like this. I could draw that by plotting a few points. This drawing is not to scale. I just want to show you these are the shapes of everything. This is how they fit together. And here's some points that would be on it. Here you see the parabola in pencil. It's got this point, negative 5 and 20 on it. Okay, because if you put negative 5 for x, you get 20 for y. It's got this point, positive 5 and 20 on it. Because if you put 5 for x, you get 20 for y. It has a vertex down at 0, negative 5. And then when I draw the line, I know that it lays right on top of the curve at the point. But it is a line that has a y-intercept of negative 30. That's what that number is. So you could plot that too. And this was what it would look like. If I plotted points, if I made tables, if I got graph paper out and plotted one point at a time meticulously, they would come together like this. Okay. But if you're not going to use technology, and I think you should know how to do things by yourself, I think it's great to use calculators, other kinds of technology that save time. But I would be worried if you didn't also know how to do this on paper. Okay, so I'm going to assume that you won't have access to technology and you may need to plot some points with an understanding of what the picture is supposed to look like. Okay, so it should look like this. Now, I could, if I wanted to, based on that, that's my reasoning, is that it's got to be this one. I mean, this is just not what a curve and the tangent line looks like. The tangent line is supposed to lay right on top of the curve at the point where they meet. They share the same slope there. And this is like as far from it as you can get almost. Okay. This one, well, this is more what it should look like, but the tangent line hits the curve at negative 5, not 5. This looks like it's over at 5 or something. So that's just in the wrong place. This one's as far off as that one, but this one does look right. Okay. I got the parabola, hits the axis down there at negative 5. I could track this point where they seem to meet. Looks like it's about negative 5 and 20. Okay, that's the one that looks right. These others really aren't even close. They aren't contenders for the graph. Okay, all right. So now I understand that to graph these together, you have to have an idea of what a parabola looks like and how to plot a few scattered points on it and what a line looks like. I mean, you have to have an idea. If you don't know what a parabola is, then this will be difficult to do from scratch. And that's something that you'd have to ask for help about. But okay, sometimes we do have graphing calculators and so on. So you could do, if you have access to it, use something like this where I plot the curve and I plot the tangent line together. And look how they look very different, don't they? Here's the curve, there's the tangent line. They don't look the same at all. But if you go over to that point where x is negative 5 and y is 20, there they both are, but it doesn't look like there's two things there. I only see one thing, right? The tangent line will blend in with the curve perfectly at the point where they're tangent. So I was anticipating that from the beginning. So that's the whole point of this formula. So it's going to push these points together, measure the slope of the line as they come together, and that's the slope of the curve where you see it. Okay. All right. So there's the story on this problem in 3 parts. I'll leave it to you from here that if the graphing something from scratch is your weakness, that you'll mention it to me. Or if you understand what it should look like and you're just having trouble getting the points to align, that's another issue, also mention to me. Otherwise, if you understand it from here, I think you're good to move forward.